Welcome back. This is Professor Fitzgerald, and in this lesson we're going to look at hypothesis testing. When doing hypothesis testing, we start with a null hypothesis, and our null hypothesis is a statement that a value of a population parameter is equal to a specific value. So, for example, we could be talking about the population proportion, P. And we could say that our null hypothesis is that the population proportion is 1/2 or 0.5. In this case, maybe we're looking at a population of campers and the proportion represents how many female campers that we'll have. So that's our population proportion. And when we refer to this as our null hypothesis, a null hypothesis is written as H with a little 0 down below, H naught. That's our null hypothesis. And our null hypothesis, okay, this is how we specify null hypothesis, is H naught. And this P, that it happens to be our population proportion. Population proportion. So it represents some specific proportion in the population. And so here we're hypothesizing that our population proportion is 1/2. And when we're doing hypothesis testing, what we're going to do is test the null hypothesis. And when we test it, there were to be two possible results. We will find that the null hypothesis is rejected. So we either reject the null hypothesis or we fail to reject. So two possibilities. We either reject it, it's not true, or we fail to reject it. Those are the two possibilities. Note that when we're looking at a null hypothesis, the null hypothesis will have an equal sign. It will always be that our parameter P, in this case it's our population parameter, which happens to be a proportion, is equal to some value. And so when we have an equal sign in our hypothesis, it is the null hypothesis. The alternative hypothesis is a statement that a parameter has a value that is different than the value specified in the null hypothesis. So now we're looking at the alternative hypothesis, and when we are talking about the alternative hypothesis, there are three ways we can specify it. We can write H1, we can write an H with a lowercase a, or H with an uppercase A. And these are three ways of specifying that we're talking about the alternative hypotheses. So when we're looking at an alternative hypothesis, we don't use equal sign. That's for null hypotheses. So we would use either less than, greater than, or not equal to. And that's when we're talking about the alternative hypotheses. And an example is we could say one alternative hypothesis could be that our population proportion is less than 0.5. Or we could say that our population proportion is greater than 0.5. Or that our population proportion is not equal to 0.5. So these are different possibilities for our alternative hypotheses. Okay, let's move these up. I think let me grab these. And what I want to talk about are our left-tailed test, right-tailed test. And so when we're talking about a p-value being less than
0.5, that is a left-tailed test. So let's draw our little normal distribution here. Here's our normal distribution. And it means that our tail will be over here. This is our alpha area. And we'll be doing a left-tailed test because we're talking about whether or not P is less than 0.5. So this is a left-tailed test. In the next one, right here, we see that P is greater than 0.05. And so this is going to be our right-tailed test. So let's draw a little normal curve. Get my pen up. So draw a little normal curve again. And in this case, this is a right-tailed test, so let's just draw a little right tail. And we're talking about the area to the right based on our alpha, our significance level. So this is our right-tailed test. Right tail. And finally, the last one, when we're talking about P not being equal to, we are looking at a two-tailed test. This is a two-tailed test, so here's our normal distribution. Oops, let me grab my pen. Let me fix that. Not very straight. Can I? I guess not. Okay, so here, lost my pen again. There we go. There we go. Okay, in this particular case, it's a two-tailed test. So we have two areas. We have an area here, which is our significance level, cut in half, alpha over 2. And then we have this area right here, which is the other half of our significance level, alpha over 2. And in this case, we have a two-tailed test. This is just something to think about as we move forward in our hypothesis testing.
Okay, so here we're going to look at an example, and our example is at least 20% of the people on a Concord Trailways bus are men. Okay, so in our example, we're going to set up the hypothesis, the null hypothesis, and the alternative hypothesis. So here we're looking at population proportion P. So our population proportion P represents the percentage of men on a bus, and on the Concord Trailways bus. And so we're saying it's 20%, at least 20% are males, and another way of expressing 20% is 20 per 100, and if you move the decimal point over twice on the top and the bottom of that fraction, we get a 0.20. So 0.20 is 20%. So we want to be at least 20%. At least, the population being at least 20% means it's equal to, there's our beginning of an equal sign, 20%. And at least means that's the least it can be. So it must be greater than or equal to 20%. Okay, so this is what we're looking for. Is the population, is this a true statement that the population will be greater than or equal to, which is at least 20%? And so what would the opposite of this be? Well, that would be that the population is less than 20%. And that would cover everything from the population being greater than or equal to 20% or less than 20%. So from these two statements, we will get our null hypothesis, and let's put that in. We'll get H naught, our null hypothesis, and our alternative hypothesis. Now, our null hypothesis, let me fix that A there. Our null hypothesis, it always has to have an equal sign in it. So our null hypothesis is going to come from this statement. This is the one that has the equal sign in it. And so our null hypothesis will be that the population of men, and we just go with equals 20%. And then our alternative hypothesis is going to that statement comes from our second possible statement, which is that the population of men is less than 20%. So this was just to give you an idea of how we set up which one is the null hypothesis and which is the alternative hypothesis. And again, we start with finding a statement that matches what we've declared up here, that at least 20% of the people on a Trailways bus and Concord Trailways bus are men, and that's what this is, greater than or equal to 20%. And then the alternative would be that they're less than 20%. So these are the two statements that we have. And then the null hypothesis comes from the statement that has the equal sign in it. But we just keep the equal sign. And then it is the alternative hypothesis becomes the other statement. So here's how we set up our null hypothesis and our alternative hypothesis. Okay, so we found our two hypotheses, and the next thing that we need is a test statistic. So we're going to test our hypothesis. And we test our hypothesis by taking a sample. And so we'll go ahead and check the get a bus load of people and find out what the proportion of men are. Maybe we'll get a bunch of buses and find out the proportion. But we're going to end up in our sample with a p hat, which is the proportion of men on a sample of Trailways buses. So what is that proportion? So we're going to go find that. That's going to have some value that we're going to find from our sample. And we're going to use that value to estimate the population proportion to find out if in fact our statements are true, our hypothesis is true, either one, the null or the alternative. So to find what we need is we need a test statistic, which is a z-score, and what we're finding is we're actually finding the z-score of our sample's proportion of men, p hat. And the formula for that is going to be p hat, that is from our sample, what proportion of men there were, minus the population proportion p that we're declaring to be 20%. And that is going to be divided by, and this is the standard deviation, the formula for the standard deviation, and that is the p, which is the 20%, times q, which is going to be 80%, which would be not male, divided by n. So this is going to give us, this is our test statistic, this value right here. This z-score right here is our test statistic, and it's based on the p-value that we get from our sample. Okay, I'm going to move this test statistic. Can I move that? No, I don't think I can. Can I move it up here? All right, let's move that up there. There we go. So I moved the test statistic up because that would be our next phase. We could sort of say the first thing we do here is, this is sort of part one, is we find out what our hypotheses are, the null hypotheses and the alternative hypotheses. And then our next step would be to find, this is step 2, to find the test statistic based on our sample. So we've gone and gotten ourselves a sample, and we're looking at we calculate the test statistic, and that test statistic is z. So we have our hypotheses, our two hypotheses, and we have our test statistic. And now we get on to the third part. And in the third part, what we're going to do is we're going to use the information that we have about our normally distributed population. So here's our normally distributed population. And what we're going to do is we're going to look at that, and here's our mean, median, and mode right here. And we're going to find out where does our test statistic lie. So this z-score right here, this z-score is going to be a value that sit somewhere on this x-axis, on this normal distribution. And if we look at our null hypothesis and our alternative hypothesis, when we look at this equality, we see that our alternative hypothesis says that p is less than 0.20. That makes this a left-tail test. So this is a left-tail test, which means that when we're given a significance level, which will be given, some alpha, which is our significance level, maybe our significance level is 0.05. If it's a left-tail test, then we're talking about the left tail of our normal distribution that is 5% of the area under our probability density curve. So we want to find out where our z-score falls. Does it fall in this left tail here, or does it fall above the left tail? If it falls in the left tail, then we consider that with the z-score falling left to the tail, we would consider p to be less than 0.20. If the z-score falls to the right on this side of the density curve, we would say that it is greater than or equal to 0.20. So now our third step, in order to find out where the z-score falls, is to find our p-value. The p-value is the area under the curve from the left to our z-score. Or actually, if it's a left-tail test, it would be from the left to wherever the z-score falls. If it's a right-tail test, it would be from the right to wherever our z-score falls. Well, in this case, it's a left-tail test, so we're going to find our p-value. It's a probability, and it's the area under the curve, and we can use our calculator. And the function that we use is the normal CDF function. So I'm going to try to squeeze this in. It's the normal, and you've seen this before. It's the normal CDF function. I'm trying to squeeze that in because we have input that has to go into it. To get to this, we just push on our calculator, right, on our TI-83 or 84. We push the second and var. See, second var, I'm pressing the buttons, and you'll see it, right? It's number 2, it's the second one down. The input we want to put in was, we are actually going from the left end of the tail up to the end of wherever our z-score falls, and I don't have any values in here for z-score. It's somewhere on here. So from the left to wherever our z-score falls. So our input to this would be, well, from the far left, let's make it -5, and then we'll put in whatever our z-score value is that we calculated. And this will give us our p-value. This gives us what our p-value is. So our last step, let me go with red. Our step number 4 is to compare our p-value and significance level. We want to compare the p-value, whatever it is, with alpha. And what is the relationship? Is it less than? Is the p-value less than, or is the p-value greater than? And if you think about it, if the p-value is less than alpha, it falls inside the left tail. And if it falls inside the left tail, then we reject the null hypothesis because P is appearing to be less than 0.20. So we reject the null hypothesis and we support the alternative hypothesis. On the other hand, if the p-value is greater than the significance level, then the z-score falls to the right of the tail. And in this case, we fail to reject the null hypothesis. We say that the p-value is equal to 120, is equal to 0.20, 20%, or greater than 20%, not less than. So this is the basic procedure for hypothesis testing, and in our next video we'll try some examples.